today, so I'm sure we can add another one. And we've become very patient because of it, so not to worry too much. It's great you're here.
All right, you can't see me anymore. Yay! Okay.
It was
still
really nice
okay?
to see you, you know? Yes, yeah.
I'll just try, let's see, whose slides? This one. I'll try these slides, make sure these work fast. This one. So you should see the ISNI slide. Change slide. I hope that changed. If you put anything on the chat,
Yes.
I can't. Okay, and I'll click again.
Yeah, no, I can. Yes, goes very fast, at least on my screen.
Good. Yeah. So let me.
Have you transformed it into PDF?
No, I just changed the resolution of my screen.
Okay.
I forgot. I'd normally do that, but I forgot this morning.
Okay.
Ciao. Emanuele Bellini is here with me. So in case we finish before 2 hours, I mean, if we have time at the end, we can show the demonstrator directly. Otherwise, we give the address.
I think that's optimistic, but let's keep it as an option, okay?
I'm always optimistic.
That's good.
What did you just say? Which was optimistic? I didn't catch that.
Maurizio suggested that if we finish early, so that means that if everybody really has short talks, that we can spend a bit of time to show the demonstrator. So now you'll understand where the optimistic element comes in.
Yeah, after the rehearsal this morning, yeah, I understand that. Let's see. We cut our slides, huh?
Oh yes, that's very
will
good.
make it,
Very
no
good.
worries.
Oh yeah. Well, I know that with you,
By the
so
way,
I have really no
so
worries there.
Okay.
I'm also going to ask, because I see several of our speakers here. While you're not speaking, can you please make a still of your picture? And the way to do it is to roll over the mouse over your video picture, and then you see a pause sign, and then because it keeps the bandwidth a bit clearer, and it makes the system go faster. And I also want to ask you that if it's not your turn, please turn off your microphone, because that also keeps the bandwidth up. And I shall ask the same thing to people of the audience once they've joined. Yes, thank you very much. Oh, what's that, Sunje? Are you cooking?
Preparing our screenshot.
Yeah, well, that's an original way of branding.
David, have you uploaded my last version of slides in PDF?
Yes, I've got that.
Thank you very much. We will record. We will record the now, won't we?
Yes, David will turn on the recording as soon as we.
Yes, in fact, it's belt and braces. I'm recording my screen because that's normally better and easier to edit. But I'll also turn on the mega meeting recording. In fact, I'll
Right. My clock is ticking towards 3 o'clock, and therefore I want to give a warm welcome to everybody who's attending this webinar this afternoon, a APARSEN webinar on interoperability of persistent identifiers. And before I start introducing the speakers to you and the program, I have a few logistical matters. One of the first is that this system works best if people turn off their microphone or keep their microphones turned off if they're not speaking. So we shall only turn on the microphone of the speaker and sometimes my microphone for the moderation. Secondly, it also works best if the videos are not streaming. So if you want to add a picture of yourself, that's fine, but please make it a video still, which you can do by scrolling over your own picture and then freeze it. You'll see the pause bars for that on the right top hand side of your own video picture if you roll over your mouse across it. Okay, I think the number of users is quickly going up now, even in this last minute. That's very nice to see. I also understand that some of our audience are joining via conference room where this is displayed on a screen. Welcome to all those people as well. I have a general question to everybody who joins and who is not a partner in the APARSEN project. We would like to keep track of your affiliation and to see from which institutes people have been joining. So if you can add that in the public chat, your name, and add the institute you're from, so that we have some idea of how broadly this webinar was disseminated. So please fill the chat form on the right hand side bottom of your screen. Okay, well then I think now is a good time to start introducing the program. Within the APARSEN project we work on digital preservation. The project is now in its 4th year. And one of the main aims of the project is to in digital preservation and to work towards defragmentation, also via setting up a virtual center of excellence. We all know that persistent identifiers is in particularly an area with a lot of fragmentation, because there are many initiatives where people are setting up their own identifier system. And this afternoon you will see some examples of that as well. Within APARSEN we've been working on an interoperability framework so that at least these different systems can be matched and mapped against each other. And hopefully some interoperability will be achieved there. In our program we have a mix of partners within APARSEN and guest speakers. I'd like to name the guest speakers first because we're very happy that you're joining today. We have Juha Hakala from the Finnish National Library, where there's been a lot of work on URNs. We have Anila Angeli of the French National Library, who will tell us a bit more about ISNI. And we have Laura Haak, the director of ORCID, who will tell us a bit more about ORCID. And from our project APARSEN, we have Barbara Bazzanella from the University of Trento. We have Sunil and Samuele Carli from CERN. And we have the lead of our project, who are in Florence, of the FRD, the Fondazione Rinascimento Digitale. I probably pronounce it wrong, but Maurizio will be able to correct me. Maurizio is also the first speaker, and he will explain more how within APARSEN we've been working on a model for interoperability of persistent identifiers. Maurizio, I hope you're ready to kickstart this. And at the same time, David will be uploading your slides. Yes, Maurizio, I can see you.
Thank you.
That's very
Thank
nice.
you very much.
I shall hand over to you now. Okay, go
Thank you
ahead.
very
The
much.
floor is
Okay. Thank you. So I said, go. We propose this model for interoperability of persistent identifier system and new services. And as you said, this is a proposal by our work group in the APARSEN project, and it's a model for to let different persistent identifier system or domain to speak each other and to exchange information, or at least to expose information in the common way. And
yours. I see that Maurizio is disconnected. Let's wait until he's back. Maurizio, you're back. I see. We lost you for a little while. Maurizio, are you there?
all the other, okay, so I'm back. Can you hear me now? Yes.
Ah, very good. Yes,
Yeah.
Yes.
yes.
Yeah. Okay.
You were dropping
So
off at the end of your introduction. Yeah, please go ahead.
I'll be very fast. So we propose a model for interoperability. All the other presentation of today are application of persistent identifiers to different domains, different user community, different business model, and so on. So this is in some way the distinction between the presentation. And why persistent identifiers? Not only because they are very fragmented, but also because persistent identifiers are really crucial and are really fundamental for a lot of services, for a lot of application, both for application nowadays and in future for long-term application, and not only for access, but also for trust, authenticity, provenance, accountability, for relation with other piece of information. For example, we think that it's absolutely not enough to think about PI resolver only for the accessibility, but we must think to many other, and we present added value services using the PI information. And the emerging of these initiatives for PI, for actors, is absolutely multiplying the potential application and services for this type of information. Next slide, please. So our model is, as I said, is not another application or a new persistent identifier domain, but it's a model of interoperability. So we will not propose a new persistent identifier technology, of course, but we propose a format, a model, a format to let everybody to expose information in a common way, no? So that we at a certain way, all the persistent domain, see, I put some in this design, can expose their data in this common format, and then we can think to develop some services across different persistent identifier. And this is something not possible now, not available now. So it's something really providing a benefit for final users, but also for the persistent identifier domain itself, because it's reinforcing and increasing visibility, interoperability, and the coverage, the impact of this system. Next slide, please. This model is suitable for any persistent identifier domain in principle, provided it respects some criteria of trust. Next slide, please. And how we develop. We very briefly, our activity in Work Package 22 has started from a wide survey on the state of art, on the current practices of persistent identifiers system, but also about user requirements, the user scenario, the possible future application or benefit from this type of information, from these type of services. So not only how you are using now, but how you could like to use, how you would like to use, what type of services you would like to have from this type of information. We develop a first model, a first proposal of interoperability framework, and we discuss with an high-level group that I really want to thank again. This for 44 experts, most of them not in the APARSEN project, who really contributed deeply in the refinement of the model and in the work of the activity. Now the last part of the project is to test the feasibility of the model and the effectiveness of the services that we are proposing. Next slide, please. In these slides, you can see the names of the 44 experts of the high-level expert group. Next slide, yes, okay. And next slide, please. The model has been proposed and presented and proposed to some events. I want to cite the last one, was very important in September. We had a workshop at the IPRES with the support of many other projects and initiatives. Next slide, please. So the persistent identifier, the interoperability framework for persistent identifier is basically based on 4 fundamental elements that you see on the screen. The first point is the persistent identifier system. We don't want to score or to make a list of the technology for persistent identifier. We don't speak about the technology, but we speak about persistent identifier systems or domain, in meaning the combination or possible combination of technology, organization, user community, specific use of data, policy, very clear and declared, publicly available policy, roles and responsibilities. So different possible organization using the persistent identifier technology to offer a specific service to a specific target user community. That's what we mean for persistent identifier system, and we will speak only about that. Then we have for some other assumption that we see now. Next slide, please. The 4 main assumptions for our model are necessary for us, for entity to be legible, to be acceptable by our model. Any entity must be identified at least by 1 PI. So a digital object must have at least 1 PI or multiple PI. The same for a person, the same for institution, and so on. So only these type of entities are eligible for our model. The second point is that we cannot accept all the persistent identifier domain, but only the system implementing some trust criteria that we have defined. And then other 2 important points. The first one is that we delegate, for the moment, we delegate to the persistent identifier domains responsibility to provide us, to inform us about relation. If a digital object has 2 different persistent, we ask the domain managers to inform us, and so on. And so we delegate them the responsibility to provide this type of information. We don't want to guess by ourselves. And the last one is that we assume, we suppose, we consider that the the manager, the responsible for the persistent identifier domains, and the user community are implementing the appropriate policy for digital preservation. Next slide, please. Here, in the next slides, there are the list of the minimum set of trust criteria that we consider mandatory for the persistent identifier system, and some of them are related to the digital preservation good practices, let's say. Some other are related to the resolver, to the resolution of a persistent identifier that we consider very important, and so on. Next slide, please. We then, after all the exercise of refining the model, thanks to the expert of the high-level expert group, we have decided to develop a demonstrator. The demonstrator is online. I must thank Emanuele Bellini here with me, and he assured me that is online, is available. So please test and let me know if it's really working or not. And this demonstrator was really necessary for us. First of all, to test the feasibility of a model to implement, but also to start testing the user satisfaction for the services that we are providing. As I said, this type of services don't exist now, are not possible now, because de facto the persistent identifier domain are isolated in most of the cases, in 90% of the cases. So we try to understand if what we guessed where the user requirements are correct, or in case to refine the definition of the services. We develop using the linked open data, the semantic web technology. So we create, next slide please, we create 3 SparkQL endpoints feeding with the contents from our content provider, and this SparkQL endpoint expose the data all in the same format, so the differences of the internal organization have disappeared. So all the domain appears to be similar or confrontable, and then we have some service provider, some engines or service provider implementing the services with a distributed query on the different SparkQL endpoint, collecting the answer and repackaging in one homogeneous format for the final users. You understand that this is not possible now, so it's something really innovative respect to the current situation, and this is clearly something strongly requested by final user, that they want to use simply and in the most easiest way this system. Next slide please. In our system we consider different types of persistent identifier domain because they respond to different user community requirements, they treat different objects and so on. So we have, as I said, our model is suitable for all of them. We have persistent identifier for digital object and for persistent identifier for actors and physical object, bodies and so on. Next slide please. In our model, we, for the moment, in the demonstrator, we have implemented the first 2. Now I explain you what type of information they must expose. A persistent identifier domain system for digital object basically should expose this type of information. Information about the resources associated to the specific persistent identifier and a simple description. Provide other persistent identifier associated to the same resource, but also provide all the different sites of the same object. No, the same object can be stored in many, in more than one deposit, and so we it's important to understand this also for sustainability, for this redundancy. Then they must expose information about other objects, other digital objects associated to the original one, translation of Italian or something like this. And finally, they must expose information about persistent identifier for access to this specific object. Next one, please, to this specific digital object. For the persistent identifier for actors, again, they must expose information about the actor associated to the persistent identifier, provide in case other identifier associated to the same actor. For example, I have an ORCID and an ISNI. So when you resolve one of these, they must inform you about also the other one. So to say this person is really the same, no? So this is important, absolutely. And then they must expose persistent identifier of digital object related to this actor. Next one, please. We have then, and this is the format of exposing data, on our demonstrator. Then finally, we have developed the first two very simple, very basic services, and we will go ahead in this on this direction. The first one is for a sort of global resolution. You can input any persistent identifier for digital objects, MBN, DOI, whatever, and the system will answer you, offering a list of sites where the document associated to this persistent identifier is available, the list of persistent identifier associated to the same resource. As I said, the same digital object can have an MBN, a DOI, and the system must tell us that it's the same document. And then lastly, information about persistent identifiers also for other information related to this, and information about persistent identifier for actors. Next slide, please. The second is on actors, of course. So you input a persistent identifier for actors, and the system answer you with the basic information about the actors, other PE of the actor, and a list of publication. Of course, our system is also capable to reduce duplication, so provide us with a consolidated list of publication. Next slide. Final one. Just to resume, this is the last one. So our demonstrator is online, and I invite again to test the system. And it's implementing the first two types of persistent identifier system, and using semantic web technology, and propose the first two services to test this feasibility, this potential application to create services across different persistent identifier as a benefit for final users. Thank you very much.
Thank you, Maurizio. Nice in time and a very nice overview. I would like to give the audience an opportunity to pose questions or make other comments. If you want to say something, just open your microphone. I can see that on my screen, and then give you the floor. I don't see anybody yet. Well, maybe I can do a quick question while David uploads the next slides from Sunye and Samuele. Maurizio, the demonstrator, to what extent is it only a demonstrator, and to what extent can organizations immediately apply it?
It's a demonstrator because for the dimension and for, I mean, for how we have developed, it's only a demonstrator, but I mean, the model is so simple. It just we didn't ask to change anything inside the persistent identifier domains. So all the people that you are speaking today, or all the experts in the high level expert group, they have confirmed this. Our approach is really not interfering with the internal organization, and so it's very simple. They just have to expose their data, and then to create the services is very simple, because you have only to make a distributed query. So
Yeah.
it's a very, very low level impact as a disturb. I mean, yeah, very easy to use, and a lot of benefit, because it's for users, for final users. They don't want to learn a different user interfaces or different formats. They prefer to use a unique. No, we know.
Okay. Okay. Very good. Last chance for other questions. If anybody wants to pose a question, please open your microphone on the right-hand side of your screen just by clicking on it. I see nobody, so I'm thanking Maurizio. Thanks a lot. And we move on to our presentation from CERN by Sunje Dalmaya-Thiessen and Samuele Carli. And they are going to tell us how they've been working on the implementation of persistent identifiers in their own library, which is a big one, just as everything is big at CERN. So maybe I can hand over to Sunje now. Sunje, please go ahead. The floor is yours.
Yes, do you hear me? Or?
Yes,
Excellent.
I can hear you perfectly
well.
well.
You hear me well?
Yes, I can hear you
Perfect.
really well. So go ahead.
Okay, yeah, it's indeed a big library or digital library we are talking about. And we indeed focus on implementation and not so much on the conceptual or theoretical background. It's really about the hands-on things we do at CERN. I have a library background, and my colleague Samuele Carli, who is the leading developer and all the author and persistent identification challenges that we face. And we are happy to answer any question because it's a very short presentation, and I'm sure there are many more questions that you have. Next slide, please, David. So what is Inspire? Inspire HAP is Invenio-based digital library. Invenio is a digital library software developed at CERN, which is going to be released in its new version in the next days and weeks. So it's something you should follow, because this comes with very, very nice features. In any case, Inspire is more than that. It's full of content, very diverse content. I'm pretty sure that many of you are aware of our preprint culture in high energy physics. So we have lots of archive papers. We do have published content from publishers with whom we have different kinds of contracts, pages, and we have integrated lots of data into this digital library in the last year. The last 2 points, authors and data, are the main focus of this presentation. We call it a large-scale digital library with a reason, because we have more than 1 million records. Half of them are available as, more than half of them are available as full text. You can do full text search on most of the objects in our digital library. Next slide, please. I don't see the next slide. Okay. This is shows you what's inside, a bit more specific. As said, archive publishers, and I would like to highlight the data business here in particular, meaning we do harvest our disciplinary and data repository HAP data. We have connections built to Figshare, Dataverse, and Zenodo, which is a data repository also by CERN, but for the long tail of science, not for high energy physics. Zenodo we use, but actually not for research data itself, but for something new, which is software snippets, code snippets, as we believe that the preservation of scholarly communication is not only about text, data, and things like this that are now discussed everywhere, but it's really to make research results reproducible. So it's also about code. This I might like to highlight, use persistent identifiers for all these objects, data, these code snippets that come from GitHub via Zenodo to Inspire. So we are the main aggregator, and we use the persistent identifiers to track citations, all these objects, as you will see on the next slide. The next slide shows you an example record of Inspire. I chose a data record because this is much more interesting than the normal textual records. You see one highlights the author lists we have. You see it's 2,800, more than that. As Yves said, we think big, and it's true in this case because it's a normal author list size we deal with. Many of them have ORCIDs already, or some of them. So we use persistent identification here too. Also internally, we had them for years already, the Inspire ID. The green highlight 2 refers to the citation recommendation that we give for this data set. It includes a persistent identifier as well. We use DataCite UIs with the Inspire Hub brand. The 3 is shows you at the bottom of the page, shows you that the data sets we have can be associated to a publication on Inspire. They can be standalone too. We have both cases. Again, here we use PIDs to connect. Sorry, persistent identifiers to connect. The 4 at the top of this screenshot is something very interesting, or I find very interesting. I hope you do. This shows citations and in parentheses 4. This means if you were to click on it, that you see 4 citations to this data set. We are able to track citations based on the persistent identifier DOI, so that researchers benefit from data reuse within this discipline. Next slide, please. The next slide shows you the author pages that I already mentioned in the beginning, which is one of the core features of Inspire and one of the core things Samuele, who will talk in 2 minutes. He's the leading developer for this. So you see 3 pillars on our author pages. The first one, personal information, where you see a list of identifiers. I have to say it's a mock-up. This is to show you under the green highlighted one, the different identifiers we deal with. We do not show publicly all of them, but of course we would show the ORCID publicly. The second pillar shows you publications and output and data sets. So we do distinguish these 3 things. We traditionally have publications. We now have data sets too, which are shown very nicely in a separate tab to really highlight and give them lots of visibility. And then the external ones is a tab where publications are shown outside high energy physics, which we pull through ORCID. If the researchers connect an ORCID to that profile, that's where we pull this additional content, so that this profile is super comprehensive. And we know that researchers use the link to this profile for grant applications, etc. And in the future, we do see that ORCID will be taking over such a role with their profiles too. The third column is stats, a very popular one where we get lots of user requests. It's the citation summary, meaning all the obviously counts of the citations. And that's where we, one of the future things we have in mind, appear the data citation. As you will see, it's not yet there, but this is yet to come. So this was a short and very fast overview of the user-facing activities, and I will hand over to my dear colleague Samuele, who will talk about the more technical background when it comes to actually producing these author pages and the challenge of authorship and author disambiguation.
Yeah, hello everybody. So as Sunia mentioned, Inspire is a relatively big repository. We have about 1.2 million documents, and we have a very high average of signatures per document. We have a lot of authors for each document, and we total about 9 million names. Of course, each person is publishing a lot of different publications under possibly different names. And in the last few years, we have been developing a relatively complicated system that tries to disambiguate the signatures and creates virtual person profiles with comprehensive publication lists for these authors. So the schema here is representing somehow what our system does. We have publications with different names on them, and the system tries to guess who these publications may belong to and creates virtual profiles for these publications. And next slide, please. Problem is that most of the times the metadata is incomplete, which means there cannot be an algorithm that is actually able to solve this problem without doing any kind of error. The system is bound to overcluster or undercluster, which means it will always assign some papers to some wrong profile or it will always miss some papers from some profiles. And this, of course, cannot be corrected automatically. So what we developed is a crowdsourcing system where the users themselves can actually connect and log into our system and give hints to the algorithm to fix the errors and to give a confirmation, a positive confirmation on if the algorithm did it right. So the schema depicts the fact that users can log in and can tell us, yes, that paper is really mine, that signature is really mine, I really wrote this, or can even tell us, no, this is not mine, please assign it to someone else. And the algorithm can learn from this, and we can end up with a very, very clean authorship data set. Next slide, please. So to summarize, what we have in the end is a quite clean connection between persistent identifiers, which are representing publications or objects, data sets, and so on. And those persistent identifiers are connected to our virtual profiles, which are holding a lot of data, personal information, and so on and so forth, which in turn are connected to persistent identifiers for persons. Next slide, please. And while most of these connections are certified by users themselves who logged in the system, and we are completely sure that this is true. So really, this person with this ORCID really wrote this paper with this DOI. For many publications, we have just an automatic guess, which is likely to be true, but could even be worse. And one of the open questions that we have here is once we want, in the framework of an interoperability framework, how do we want to represent this fact, if we want to represent this fact, so that other systems can actually distinguish between these different importance of connections. So important confirmed connections and guest data. Next slide, please. I will finish describing how we relate with the interoperability framework. We developed a general system for Invenio, which is then available to whoever is using this software for a digital library, to export the whole data set given a configurable ontology. So in general, starting from your entities, papers, and profiles, you can configure via XML file an ontology, and this will be transformed in triples following your ontology. And what is important about this system, which is probably useful in this context, is that you can configure multiple ontologies. You can export your data at the same time, different subset of data on different ontologies, hence amplifying the interoperability opportunities that one has. And last slide, please. Once you created these triples, you want to expose them in a SPARQL endpoint. And the challenges we are fighting with at the moment are scalability problems. With this file, we would have to export if we were to export all of our data, order of 1 billion triples, and we of course want to stick with open source solutions. So anything which is not open source is forbidden somehow. And there are not many open source solutions for tripod stores. There are 3 of them which are the most important. But without specialized hardware and big clusters, they don't scale really well. And this is what we are working in this moment. We are trying to figure out how to scale these systems so that we can actually export all our data in a system that will be queryable in real time, and you will not have to wait long to get the results. And I would stop here and open the ground for questions.
Thank you, Manuela, and also thank you, Sunye. Let me see if there are any questions. If people want to ask something, just turn on your microphone by clicking on it. It's red now, it will then turn green. And I don't see any questions here. Okay. I have a very short
So if
question.
there are no questions,
yeah.
Sorry, if there are no questions, you can also just drop us an email. We are almost 24 hours online. So,
Oh, really? But that is a very fast reaction time. Actually, I had a little more question out of curiosity. If authors can react to confirm that they are the one who the system thinks they are, do they usually react very quickly?
Yes, we did some crowdsourcing tests, not particularly with this system, but before we deployed it. And they usually reply within 24 hours. Then we have another peak 48 hours later, and then there's a long tail of random reactions, but it's very fast usually.
Okay, well, that's encouraging, because then the system works apparently. Okay, very good. Well, thanks again to both of you. And we're now going to switch to Finland, where we have Juha Hakkala of the Finnish National Library. Outside speaker, Sunye, Samuele, and Maurizio are APARSEN partners, but Juha is our first guest speaker, and he will tell us more about URN standards and how you've been working on a revision of it and what it means for persistent identifiers. Juha, if you are ready, please go ahead.
Hello, greetings from Helsinki, and I'll discuss about interoperability from a slightly different point of view, which is the standardization. And if it doesn't sound riveting, then that is because it is not riveting. Could be a bit boring at times. But the challenge we are facing is that we want to make the persistent identifiers a lot smarter than what they are at the moment. We really need to provide a lot of new services in the future, and all this has to be done or should be done so that the different persistent identifiers remain interoperable. And this is a kind of non-trivial thing to do from standardization and also from technical point of view. Next slide, please. First, I think it's good to say something about what I mean with interoperability in this case, and especially I'm going to discuss a little bit about syntax and semantics. Syntax meaning that persistent identifiers could and perhaps should be aligned with the URI generic syntax, which particularly means that we should be able to use query and fragment. And the way we use them in persistent identifiers may not be exactly the way they are used in other contexts in URIs in general. And then in semantics, the interoperability just means that the resolution services supported by different systems should be more or less the same. So for instance, ARC at the moment supports a service that no other persistent identifier system can. With ARC, you can check the preservation commitment of the organization that is holding a preserved document. And this is something that no other persistent identifier currently can do. Next slide, please. When it comes to standardization of the persistent identifiers, then there is one ring for them all, which is the IETF. Almost all persistent identifier systems started from there because persistent identifiers are something that are used in the internet context. But given that these systems were introduced in late 90s, we still haven't really gotten too far. No system is on standards track in IETF. Both handle and URN are just informational RFCs, and ARC is just an internet draft. So there is really a good reason to strengthen the standard base. So IETF established the URN BIS working group a few years back to modernize the URN standards and elevate their status to the IETF standards track. DOI is the only system that has been standardized elsewhere. It's in ISO, but it's only the DOI syntax that has been specified there. And the handle nowadays is being managed by International Telecommunications Union. Next slide, please. So the URI generic syntax and URNs, there is currently a slight conflict in the sense that the current URN syntax, these query and fragment are reserved, but there is no explanation of how to use them. But the latest version of the internet draft for the next version of the URN syntax then says that both query and fragment can be used. But they are not part of the namespace specific string, so that means that they have no role in identification. They don't identify anything, but instead the query can be used for sending resolution related information to a resolver. So you can specify the service and parameters related to the service in a query. And then from URN point of view, the fragment only indicates a location within the document that has been identified by the URN namespace specific string. And that makes it possible that fragments and queries can be added to URNs after the URN has been assigned to a document. And anyone can do this because really fragment and query are not part of the bit of the URN that identifies something. Next slide, please. From a persistent identifier point of view, there is nothing problematic in this, but unfortunately, the URI generic syntax RFC 3986 claims that fragments actually identify something. And this is a kind of major philosophical issue to most URN namespaces where there are quite strict rules on how to assign identifiers. So this, as regards fragment, the URIs and URNs should be different, and this applies to all persistent identifiers out there. Next slide, please. The next slide. When it comes to query, also the URI generic syntax kind of insists that query most of the time identifies something, which is a fairly problematic point of view from PID community. So what we need is kind of a separation between URNs and URIs. And this has been something that is kind of difficult to accept in IETF community, and especially in some other communities like W3C. So we haven't really been able to get this kind of philosophy approved in the URN BIS working group. And even now, I'm personally not fully certain that the URN BIS working group will be successful in what it is doing, which then raises question of where should we then specify the next generation of URNs if we can't find an agreement in IETF. Next slide, please. At least my take on this is that we really do need an extended specification for URN syntax, which enables us to use query, because we need a kind of flexible mechanism like that to make URNs smart. And this slide shows you how, for instance, we could use query to enable the user to require not just a document itself or the location of that document, but a metadata about the document in a preferred format, in this case Dublin Core. These URLs in the slide, they look a little bit cryptic, but the slide on the bottom, which the URL on the bottom, which is an SRU query, it can be constructed automatically by the URN resolver. It only needs to know the target system where to send this kind of query. So this processing can be done automatically, although the strings on the slide look a bit complicated. Next slide, please. So fragment is technically not challenging, and there we only have this kind of small philosophical issue that we need to get rid of the idea that they actually identify something. But query is far more complicated, because when we start using URI queries for passing requests to resolvers, then somehow we have to agree on what kind of queries shall be constructed. So if we want, for instance, metadata about the resource, we have to have certain kind of query which can then be understood by all resolvers, no matter whether they are dealing with ARCs or handles or DOIs or URNs. Otherwise, we shall have plenty of confusion. And next slides will describe you how we are planning to solve this problem. So next slide, please. So currently we have RFC 2483, which specifies a fixed and very insufficient list of resolution services. But it is impossible to specify a list that would be good for a long time, because new applications, new kinds of material types, all will enable and make necessary additional resolution services. So we have to have a place where you can easily add a new kind of services and new kind of parameters to them. For instance, in a digital archive, it has to be possible to compare successive versions of a document and see what differences are. And with preservation metadata, you can do that, but there has to be a way of passing this request to resolver and then on to the target system, to the digital preservation system. So the idea is to have a registry by Internet Authorized Name Authority, where it would be quite straightforward to add new services and service parameters. And this would be available for the entire persistent identifier community, not just for the URN system. Next slide, please. So this is an example of how this might work in practice. It's a service where we can require metadata about the resource. Currently, you can't really say anything about it. You can just require metadata, but you can't specify a format and protocol related to it. So what we need is, we need to give quite a lot of details in the service registry about this single service. We need to be able to specify a metadata format and the version of the format. We also should be able to specify the completeness of the record that we are asking for, and maybe also retrieval protocol that is used when making the request. So you can see that making resolution smarter, making the persistent identifiers more useful to the end users, it's not kind of trivial, but it is certainly something that we can do. And UI queries have been identified as a kind of efficient means of passing this kind of information to resolvers and then on to the target systems. Next slide, please. So once this kind of fairly complex specification has been done to one persistent identifier system, then ideally, really, we would want to enable same kind of functionality in other systems using the same kind of specifications in queries. Currently, we really don't have a very good interoperability between the systems. As I said in the beginning, different systems provide different services at the moment. But as far as I can tell, there are no conflicts between the systems. So it is still quite easy to create a single list of services and then enhance all the systems in such a way that they are semantically identical. But if we don't do anything, then there is a fairly good chance that eventually there are conflicts between persistent identifier systems, which would then undermine the idea of making these systems interoperable. And this was the last slide in my presentation. It's time for questions.
Thank you, Juha. That is very clear. Let's see if we have any questions. People who want to pose a question can simply turn on their microphone, and I will see that.
I have a question.
Yes, I just saw your name.
I have a question.
Go ahead, please. I see another question as well.
Sì.
Go ahead, Maurizio.
Sì, very fast. Yuka, you have participated in the group, in the work group, no, in the expert group, working on this proposal for this model. Now, you have confirmed that there are a lot of services working for specific domains, no, of names. So we have isolated domains in some way, and you are confirming that we need to put together these services to make interoperable these services, and also to make more added value services than just a resolver. So
Yes.
now a question: can we think that our approach, proposing a model, asking all persistent identifier domain to expose the data in a common way that can be confrontable, can be usable at the same way, can be a base on that we can build these services across different PI domain or not? So, and in case, how can we go ahead? That's all.
I think it's a good starting point, at least. Of course, one thing that that would be useful is to check all the persistent identifiers and all the services that are providing, because if something has been seen as relevant by one community, there is a good chance that it will be useful for other communities as well. For instance, this feature in ARC that you can check the preservation commitment, it is certainly useful for any other persistent identifier community where some of the members need to preserve some documents for long term. So this kind of activity of collecting these services together and then checking candidates for new services, that would be a good starting point for it. And then how to implement that in practice would be the next step.
Okay, thank you. I saw a question also by Martin Dow. Martin, please go ahead.
Oh, hi. Sorry, I didn't actually intend to press the microphone there, but I felt that was very. I think it's just turned itself on, but I found that a very interesting presentation. Thanks. And just a little comment here as to whether you've considered audiovisual media at all, because you made several statements about fragments, and we've just completed a project, European projects on audiovisual fragments and or URIs to resolve fragments, and it's going to be a big question, even if it might not be now. I note under DOIs and entertainment identifier and using them for rights and so on, that there are different definitions of fragments, and I'm aware that already URIs, you have to excuse the banging, sorry, some construction work going on, that people are using fragments already for identification purposes. They're beginning to harvest data and index it and assume that within audiovisual media that there is a reliability within the HTTP URIs referenced under W3C media fragment specification, for example. So I'm just sort of pointing at the future a little bit, and with this sort of abundance of audiovisual media on the web and beginning to be used in evidence, so preservation will come into it very much so. Yeah, I just wonder if this had been considered in any detail within the scope of this project.
Yeah, that's a nice aspect. Please go ahead.
When we are revising the URN system, we really haven't been discussing in detail about any specific media types. But there is a feeling that if we fail at specifying how the fragments and queries should be used with persistent identifiers, then people will start using them in any case. It's just that this usage will be uncontrolled because there is no documentation out there telling them how to do it. So we will have all kinds of queries, and that will be the main problem. As regards fragments, I think one concern that people had in IETF was that fragments would not be persistent when used with URNs. And people had difficulties understanding the concept that some identifier systems are manifestation driven. So you don't pass them to the next version of the document. I think the unit fragment is very likely to be far more persistent than URL and fragment.
Okay, just to come back on that, thanks very much for that answer. I fully agree with you, and I think that essentially some steps that take that sort of provide organizational commitment and therefore trust, I think, towards semantic interoperability is really key, and I think this is where you're headed with this, and I just fully agree, and that already I believe that there's some uncontrolled usage of the semantics around fragment and query.
Technical issues aside, I think the main difference between persistent identifiers and cool URIs is administrative one. The persistent identifiers, as a rule, are a lot better managed than cool URIs, and this has a major impact on persistence. But really, we are dealing with three different communities here. We have people who are actually using persistent identifiers and see the importance and usefulness of them. Then we have a group that could be called engineers who are listening to the arguments of cool URI camp and a persistent identifier camp, and eventually the group that has best arguments and results to show will win over. And then we have what could be called fundamentalists in W3C camp who just don't listen because they believe that cool URIs are sufficient and anything else is just unnecessary overload.
Agreed.
Okay,
I've just come back from Helsinki. Thank you for the OR 2014 events, which I'm sure you probably had. So I agree on the persistence points in practice over our holdings. So thank you.
Well, thank you very much, because that added a very interesting aspect to the discussion. I'm looking at the clock because we still have 3 speakers to go and then our conclusions. We make a jump from Helsinki to Paris, and there we go with a big thank to Jukka Hakala. Thank you very much. And in France, we go to Anila Angeli, who works at the National Library of France and who works with ISNIs, yet another persistent identifier.
Right.
Anila, go ahead. It's yours.
Thank you. Hello, everybody. So I'm Anila Angeli. I'm from the National Library of France, and I am talking today as a member of the Board of Directors of the ISNI International Agency. Next slide, please. Yes, what is ISNI? ISNI is an ISO certified identifier. It's the international standard name identifier, that's its name, about the public identities. That is, the identities that individuals or organizations manifest in their creative activities, and that is all for persons or organizations that create, produce, manage, distribute, or feature in creative context in whatever role, that is writers, artists, creators, performers, researchers, producers, publishers, aggregators. So this is a non-finite list, which means that ISNI as it was a response to a long-felt need to all the communities that needed to share information about the public identities, that is, persons and organizations. And that's why we talk of a universal scope of ISNI, and of course, with a strong requirement for uniqueness, persistence, trustfulness, and how could this be achieved? The decision was taken within the ISO working group and the consortium that was created then to manage this centrally in a central database. And yes, for now it is also expressed as an HTTP URI. So cool URI, but I'm not going to discuss about this because you did it perfectly. Next slide, please. So I talked about the fact that the decision was taken to manage the identities centrally at the international level, because this was the only way to ensure all the problems of disambiguation and data application and the fact that of avoiding mixed identities. As you can see on the slide, the cylinder that represents the international database of ISNI, in the upper part, we have 8 million identities assigned today that are accessible on the web, and they are diffused throughout the data contributors. And the down part of the bottom part of the cylinder represents all a huge information records about these identities that are not yet assigned an ISNI. Why? Because they do not still fulfill the criteria for confidence in the assignment, because they are not authoritative yet information. The 8 million, nearly 8 million assigned is considered as authoritative information, disambiguated, unique, trustful, and persistent. Next slide, please. Right, Maurizio, one of these is you. Some figures that are in consistent growth. The database started in November 2011 with only 15 data sources that loaded data in the ISNI central database in order to match and disambiguate and consolidate identities. And today, in June 2014, we are with more than 70 data sources, including all the VIAF contributors. You all know VIAF, I suppose, and 30 other data contributors, including publishers, rights management societies, professional and research societies, universities, trade sources, etc. And the number of the ISNI society, I mentioned nearly 8 million. Today we are precisely 7.98 million, and knowing that the database started in November 2011 with 1 million. You have broken in the table below by categories, but I'll let you see more precisely by yourself. I will just mention the fact that are more than 800,000 identities of researchers, and given that ISNI identifies organizations, that is corporate bodies, that are more than 400,000 organizations already identified in the database. Next slide, please. So in the two next slides, yes, you have the list of the data contributors in the ISNI central database. I would just mention that here you have all of them mentioned, and in the general sources you have VIAF, and in the next slide you will have all all the VIAF contributors. Next slide, please. Right, so you have only the list of the VIAF sources, knowing that there is a strong interconnection between VIAF and ISNI, and a regular workflow between both systems is on place, and they tend to be synchronized little by little. And this is one of the major activities between both systems, VIAF and ISNI. Next slide, please. So given that you have seen the variety and the multiplicity of sources in ISNI, ISNI is positioned as a cross-domain identifier and as a, an identifier hub. So this we can see better in the next slide, please. I'm not yet seeing the next slide coming. David, the next slide, please.
You should see it in a moment.
It's frozen. Oh, thank you. Yes, so this kind of illustrates the idea that ISNI is bridging those different domains from which data is loaded in the database, which represents trade sources, archives, museums, so cultural heritage sources, libraries majorly. Then there are a lot of databases and data sets that have been loaded in ISNI that represent researchers, professionals, theses, and articles databases, granting organizations, and so on. You can see the logo of ORCID and Odin, for example, because there is strong collaboration between the ISNI and ORCID. ORCID has chosen ISNI for the identification of the organizations to which the researchers are affiliated. And then it goes on with encyclopedia sources, with music rights, text rights, and so on. The idea is that though bridging domains, ISNI enables a linked data value chain. Next slide, please. So, well, this is a little bit ambitious, but knowing that the landscape of the PIDs is fragmented, and we're talking about persistent identifiers, though we don't exactly know at what level each of the identifier is positioned. This is an effort to represent the different layers of identifier for authors and other contributors. In the bottom layer, we have different institutions of different types. Each of them has its own local ID system, working in local environments. And each of these institutions may participate in networks operating at regional or consortium level, and I'm giving here only examples. I'm not pretending to be comprehensive in this presentation. For example, you have the NACO, the Name Authority Cooperative, managed by the Library of Congress, or the GND in Germany, or the DI in Netherlands, or in French. The IDREF, that is the identifier for authorities for the whole university system. And each of the institution at the bottom level may be connected to one network, precise network at the regional or consortial level. And then there is, we're witnessing this last year's, 10 last years, this international initiative focused on specific communities of users, such as ORCID. Oh, everyone is talking about ORCID or VFID. And there are two other that are not so well known, but known in their own communities. That is the international party identifier that works in the management of rights of authors and composers, and the IPD, international performer database identifier for the performers' rights. And ISNI at the ISO level and as a joint initiative of different communities was devised as a bridging identifier for these different layers of identifiers. So we may agree or not to that vision, but that is the idea behind, and you'll see how it works also in the database. Next slide, please. So the next slide will be just a snapshot, or that rather a patchwork of pieces of snapshots from a record in the ISNIT database that gathers a lot of information. Sometimes records are pages and pages of screen. And so in the bottom, you can see all the sources, data sources that have contributed to consolidate this identity. In the case, I didn't take a big risk by displaying the record for Louis Pasteur. On the top, you have the ISNI as a cool URI, expressed as a cool URI. And you have a yellow box there that gives the possibility to end users, any end user on the internet can click on that box and fill in a form to suggest ameliorations or to make comments on this or that record and identifier. And if he provides an email, he gets a response from a team that monitors all this feedback. Next slide, please. Which shows that behind the ISNI there is a whole governance and control infrastructure that is supervised by the ISNI International Agency, that is the ISO registration authority for ISNI, that relies on two main pillars for all that is control structure: the ISNI assignment agency run by OCLC and the quality team composed by experts from two libraries, the BNF, the My Library, and the British Library. And then the whole network is being built and is growing with two major type of players, that is the registration agencies that can act on behalf of themselves and on behalf of others, and members that can act only on behalf of themselves. And you have also featured the end user in this whole system and communities that is being created. Next slide, please. Which will talk about the data curation that is the cornerstone of the system. I talked about the trust, I talked about the database, I talked about all the criteria for the assignment and the confidence criteria. And this is managed by, on one side, the ISNI quality team that samples data regularly, checks for mixed identities and applications, makes corrections, merges, splits, does error notification, has privileged access to the database, and makes system recommendations. We also respond to the end user input, as I mentioned before. And the assignment agency run by OCLC that processes data algorithmically. So there are matching algorithms behind, running all the time, sampling the data, and R&D activities to enhance the quality of the database, and especially managing the links between the data sources. And you have the data quality policy that is published on the web, and you have the link on the bottom of the slide. Next slide, please. So I have, how much do I have still? 2 minutes, 3 minutes?
Well, actually less, but if you can round off in 1 or 2
Okay,
minutes, that would be
I'll go through this very rapidly. I just wanted to talk about one use case to make you see in the more concrete terms the how the ISNI can help consolidating identities. At the BNF, we have already ingested 1 million ISIs, and we have integrated work with ISNI as the day-to-day basis of the authority work. Next, please. The ISNIs then are diffused. Yes, they are diffused in our linked data service, the data bnf.fr, and through all our patrons through the bibliographic data supplies, libraries, publishers, and others. Next, please. And then there is a whole strategy with ISNI around consolidation of French identities that is being constructed with the publishing industry for identifying authors before publication, streamlining workflows, etc. With the cultural heritage data on the web, the large data, cultural data databases, with the researcher domain for the identification of researcher and connection with the higher education university system, and for the management of rights in digitization, and of course with large data aggregators as the European Library and Europeana. And the last slide is just a more precise vision of how dataset can be linked in a trustful way on the web and on the semantic web, and wherever you have the symbol of the RDF triples, it's about linked data. So I have finished, and on the last slide you have contact information and access the link toward the ISNI central database. Thank you very much.
Thank you, Rila. That is all very clear and interesting to see how quickly ISNI got so far. Let me see if there are any questions in the audience. People can click on the microphone, and then I can see here on my screen if there's a question. I don't see any. I'll do a very quick question, and I would appreciate a really quick answer. You have to watch the time on it. The model as developed in APARSEN for interoperability, as Maurizio showed it in his first presentation. How well would that work with ISNI? Would it really be, as Maurizio said, a very low interference and easy to use?
I think that given that the identities are curated, consolidated in ISNI, and there are already links to works through other identifiers, that is the ISBNs, the DOI, and what else, other identifiers from the authority files in existing other systems, whether ARCs, on NBNs, etc. If information from ISNI is put in the APARSEN platform, it is a very good asset, because with 8 million ISNIs assigned and 16 million links to other identifiers of the data sources, this brings a huge amount of data and interconnection between the existing identifiers, I think.
Okay. Okay, thank you very much. Right, then we move on to our next speaker, and that is a jump across the ocean because we go to Laura Haag in the US, and she's the director of ORCID. Laura, I see you've turned on your microphone. Laura's going to tell us a lot more about ORCID, how it connects people, places, things as an information hub. Laura, the floor is yours.
Thank you. So I'm just going to warn you that my wireless is a little funky, so I apologize if I cut out in the middle of this. Why don't we just move straight to the second slide? ORCID was founded specifically for the research community, researchers and contributors. We obviously have an issue here. The second slide, please, with addressing name ambiguity, and in particular name ambiguity in scholarly publishing. And the reason ORCID was founded was really to get a sense of and provide the tools for individuals to get credit for their work. And it's hard to get credit for what you've done if people can't find what you've done. So here on this slide, you can see a number of different ways that people have named problems when we're trying to use name strings to parse and connect information. I think everyone on the call already knows this. I think one of the things we run into with ORCID is people keep thinking about persistent identifiers for people as a way to deal with common names. And it's much, much more than that. There are people like myself who has really uncommon names, but still have issues with name ambiguity because their names have been spelled differently, expressed differently, using initials, etc. There's folks, I have this great example of Jens Agersmerup Sorensen from Sweden, actually not from Sweden, he's from Denmark, who has serious issues because his name, he has 4 names and special characters. It's just like the absolute holy grail nightmare of name ambiguity. So there's certainly a reason to have persistent identifiers for people. So if you go to the next slide, we run into naming issues as well for organizations. So this isn't just about names for individuals, but there's also names for organizations. And obviously this is something that ISNI has been working on, is persistent identifiers for entities, names, and organizations included in that. And so here, if you just list a person and have an identifier for the person and perhaps an identifier for the work, but don't have an identifier for the organization that they're associated with, things start falling apart again. So ORCID is really interested in persistent identifiers, not just for one piece of this puzzle in the scholarly communication space, but also in linking these identifiers for people to other identifiers. And in this, I apologize for the noise in the background. It's really important for us to be working with other organizations, other PI domains, to ensure that these are linked together effectively. So what is ORCID? For those of you who aren't aware of what ORCID is, we're an independent, not-for-profit organization, and we collaborate with researchers and organizations across the research community to provide a registry of unique and persistent identifiers for researchers. The ORCID identifier is a 16-digit number. It's expressed as an HTTP URI, and it is compatible with the ISO standard. And I'll talk a bit about how we're working with ISNI in a few minutes. So this has been mentioned before, this idea of an information hub. Sorry, I'm like 2 slides ahead of you. Keep going, the slide after that. ORCID connects researchers with their works, their organizations, and other identifiers. Go one more slide forward. And what you can see in this slide is, in my view, of course, ORCID is the center of the universe. I know that's not what it is for other people, but for the point the point of this talk, let's just talk about my perspective on things as a person involved with ORCID. You can see how the ORCID identifier, at least schematically here, connects with a number of other identifiers. One of the key principles for ORCID is also a key principle for APARSEN, which is that for actors and objects and organizations to be associated with each other, a key piece of that association is a persistent identifier. So we connect with other identifiers for people, including ISNI, internal identifiers at universities and funders, as well as researcher ID and Scopus author ID, so identifiers for authors. We connect with funders and identifiers for funders, whether that is the fundref identifier or the grant ID of the grant itself. We connect to identifiers in higher education and research employers. So this would be an ISNI for the organization, the Ringgold ID for the organization, as well as internal IDs at those organizations. We connect with professional associations, the member ID. A number of associations are integrating ORCID into their membership workflows as well as their meetings workflows. We also connect with repositories. A number of repositories have integrated ORCID into the deposit process. So here you have linkages with DOIs for data sets, with ISBNs, with thesis identifiers. Organizations are starting to request or require that their graduate students include an ORCID when they deposit their thesis into their ETD process. And then finally in this loop, integrating with publishers. So publishers asking for ORCID identifiers, and somebody submits a manuscript. And a number of publishers are starting to also do the same, not just for the corresponding author, but also for all of the co-authors on the paper. And obviously, this is a challenge in the high energy physics community where you may have upwards of 200 to 2,000 authors on a paper. How do we manage that process? And that's something that we certainly need to work on a little bit more to make that not a laborious process for authors. But in the same mean there, it's also a huge opportunity to look at how do we integrate not just ORCID identifiers into that process of authorship, but also determining author role and validation that the co-authors actually have agreed to be co-authors on a paper.
Are you still there, Laura?
So I think in all of these different workflows, ORCID is being integrated in their affiliation and their research author. So next slide, please. This is a little bit more statement on our interoperability with ISNI. I'm just going to plow ahead here because I know the slides are getting updated as we speak. Oh, shoot, did I fall off? Can you hear me?
Yes, I can hear you now. You were
Can you hear
away
me?
only half a minute or so a while ago. Yes, I can hear you. Can you hear us?
Can you hear me?
Okay.
Okay, I'm back. Sorry. I told you I'm
Yeah.
kind of cutting
But
in
your
and out.
slides are very clear,
There we
so
go.
don't worry.
Yes, I can hear you fine. So this next slide talks a bit about, we do have a joint statement on interoperation. We have a three-part technical implementation plan that we've been working on, and the piece that ORCID has been working on is the ability to link ISNI identifiers with ORCID records. That part of it, a particular tool, was launched last fall. The fun part about that tool is it not only allows a person from the ORCID interface to link their ORCID record with their ISNI ID, it also uses ISBN information that's in the ISNI record to then link the ORCID record with that ISBN and pull in metadata using the ISBN API. So that I think is very much in the spirit with what APARSEN is talking about, is using these persistent identifiers and resolving systems to be able to harvest information and pull it together, very much research focused. So there's next slide, please. Another project that Anila alluded to was the ODIN project, was the ORCID DataSite Interoperability Network. And through that project, which we've been funded by the European Commission, we've produced a couple linking tools. One is the ability to link ORCID with DataSite. There's an ORCID DataSite metadata search that allows an individual to find their existing data sets and link to them. On the DataSite side, they've adjusted their metadata so that when somebody deposits to a DataSite center, they can now include their ORCID identifier in that deposit. So that's a really great way at the time of deposit to link an individual contributors with their data set. The other piece that I just mentioned was this ability to link your ORCID record with your ISNI record. And I've shown you two screenshots there. One is from the ODIN project website. The other one, the ISNI to ORCID search and link tool, that's actually what it looks like in the second step as you proceed through that linking tool in the ORCID interface. I think the important thing here that I haven't mentioned yet is that ORCID uses an OAuth 2 process to authenticate so that when an individual uses any of these search and link tools or any of the integration, so publisher, funder, university, etc., integration, that happens using authentication. So it's not an individual typing in their ORCID identifier, it's an individual logging into their ORCID record, and then the APIs passing that information back and forth. And, you know, so I just want to make that really, really clear, is that we really want to discourage people typing in any kind of identifiers and really encourage, again, in the spirit of APARSEN, the use of APIs and computer-computer interactions to interchange information between computer systems. All right, next slide, please. What you see in the next slide is a screenshot from the ORCID registry. This is my record. You can see we have 150,000 users that have registered for an identifier in the last 2 years. And you can see on this page that I can show multiple variations of my name. All this information is accessible through our APIs. You can show up my country, keywords associated with my record, as well as a link to my LinkedIn page, but also other identifiers. So here you can see my ISNI ID, my researcher ID, and my Scopus author ID all on this page. And on the top, just underneath my name, you can also see the expression of my ORCID ID. Again, because a number of IDs out there are expressed as 16 digits, including your credit card, it's really, really important for any display of identifiers to include the full URI. I know that there's always conversations about this, but we really encourage even publishers when paper to include full ORCID identifier in there, not just the 16-digit ID, because that is very, very confusing and not resolvable. All right, next slide, please. So interoperability between systems is not easy. It does require agreement and use of shared standards and the ability to resolve data entities. And as I've been saying, this is really important, not just for one piece, but also for all pieces. So kind of the whole sentence, right? The person, the place, and the thing. What is it that we're trying to understand? We can't just do this with resolvers for the documents. You have to understand who wrote the document, who made contributions to the document, but also what organizations were involved in funding the document or supporting the researcher or scholar that produced the document. So you have to have identifiers for people, places, and things all together. We need to find a way to work together more effectively in this community. Next slide, please. And this is, next slide is really, again, stating what Maurizio talked about at the very beginning. What are some of the standards that we need to work with and work together on in the community? I would say that in reading the documents when I first became part of the high-level expert group that was reviewing the APARSEN findings, it was like, yes, 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 this is exactly it. We, you know, at ORCID consider linking to entities only if there is a persistent identifier available. So it's very difficult for us, for example, right now we're having a whole conversation about how do we link to reviewer service. So somebody's peer reviewed a paper. If there isn't some kind of identifier for that peer review activity, it's not something we can link to. So people want to link to it. So then the question becomes, well, if we're going to link to some acknowledgement of peer review service, then there has to be some kind of identifier associated with that service activity. So that launches off a whole other conversation in the community about how to accomplish that. But I think that's a good thing. It means, you know, the linkage in ORCID, on ORCID side might take a little bit longer, but when it does happen, it means the linkage is resolvable, and that is super important. The persistent identifier, point 2 here, must meet certain trust criteria. They have to be persistent, right? They have to be resolvable. They have to be unique. There have to be specific registration policies. There has to be a defined user community and independence, right? So it's always resolvable. All these things ORCID follows. It's also part of the APARSEN requirements. And there's also a shared core ontology. One of the things we do at ORCID is we realize there's all kinds of metadata that could be associated with a record. Frankly, we don't care about all the metadata. We care about the persistent identifier and then a minimal set of metadata that helps an individual say, yep, that's mine. But really what we want to do with ORCID is allow people to link between the person, the place,
Laura, we lost you, I think. At least I don't hear
and
you.
then resolve
Yes, you're
using
back.
that persistent
Sorry, you were
back to the
gone
actual
for a little
source
while.
the definition array and research data exchange standards from the folks at Eurocris, like the Serif metadata standards. So very interested in working with other folks on other pieces of thanatology. Up, okay, hang on. I'm floating in and out. Am I here? Am I here? Just tell me when you can hear me.
Yes. Yes, we can hear you now. Yes, we can hear you.
Can you hear me?
Yes.
Okay, I'm back. Sorry. Okay.
You're holding on.
I love
in
my
a brave
wireless.
way.
Okay, I'm almost done. There's 2 more slides. Okay, and then digital preservation. Yes, not a digital repository. We preserve the links and we preserve the information in the ORCID registry, but we do not hold the source documents. We point to them. And so we do rely on those PI domains, those entities that are managing the papers, the data sets, et cetera, to preserve those. So we'll move on to the next slide before I fall off again. So the next slide shows a screenshot of the actor resolution component of the APARSEN demonstrator. And so this was kind of fun. It looks to me a little bit like the ORCID page, but what you can do here is, in this case, type in your ORCID ID or your ISNI ID and use that to then harvest information across domains and bring it all together. I think one of the very powerful things all of this interoperability work is the use of APIs and the ability to manage privacy of data on the user side of things. So what ORCID does is provide those privacy tools and put them into the hands of the individual so they can manage what they want to share and what they want to keep private, but using those APIs of information around and making those APIs open. So APARSEN is using the public API to pull public information from the ORCID record and display that in this demo. So I'm very, very excited that this works through the public API. I'm hoping, and I know that a lot of other people are using this public API. And there's also additional benefits using the member APIs, which obviously require a membership fee, but ability to move this data system to system is really, really key in what ORCID is all about. Next slide, please. And this is another piece I just wanted to mention that has to do with provenance. So it's all fine and good to have a system that allows an individual to say, this is mine, and a system that takes persistent identifiers and embeds their collection into existing processes like manuscript submission or grant applications or thesis submission or dataset or deposits. But it's also really important to collect provenance of that information, the date the manuscript was accepted, the journal that it's in, the repository source of information. So all of the ORCID data records not only include the basic metadata, title, abstract, author, title, author list, things like that, but it also includes provenance information for source. So who made the link? Was it the individual making the claim? Was it something that came out of manuscript submission and accept peer review process? Was the affiliation link made by the individual? Was it made by their employer? And so that piece of the information is also consumable using the ORCID APIs. And what we're working on now is a method to allow trusted parties, so these would be ORCID members, organizations, to
I fear we lost you again, Laura.
validate self-claim information. So an individual claim. So that's a piece we will be rolling out over the course of the next 6 to 8 months. And I think adding to that provenance and trust of the information that is made available through the ORCID registry. And that's all for my slides. I hope we come slightly closer to time. You can go one more slide forward. And I always pull quotes off of Twitter. There's a really nice one on here. There's, yes, many uses, not the least of which is name disambiguation. And it's very painless to get one. So what I probably didn't mention in here is that individuals can obtain an ORCID identifier completely for free. It takes about 30 seconds and for the community to use for free. So from the researcher's point of view, ORCID is fairly painless to use and costs them absolutely nothing. So thank you very much. I'm open for questions, or you're very welcome to send me an email or send a note to our support desk if you have any questions about ORCID. Thanks.
Thank you, Laura. And very nice how you addressed interoperability as such a core element in ORCID. That is really very nice. We're running a bit out of time, but let me see if there is a question. We have room for one question, but I don't see anybody. So in that case, I suggest we move on with many thanks to Laura. Thank you. And we only missed you a few very short bits, so not tell us about the entity name system if it is pulling forward the slides. So I move over.
Okay, I can start now. So I'm Barbara Bazzanella from University of Trento. My presentation today is about a technical solution for implementing a digital identifier interoperability infrastructure. Next one. Next slide. The goal of my presentation is twofold. First of all, I want to introduce the entity name system that has been developed during the European OCAM project. In particular, I want to focus on an evolution of this system toward a technical infrastructure for identifiers interoperability. Secondly, I want to show how the proposed approach can be used to integrate information from different persistent identifiers authorities, but also to bridge the gap between the persistent identifier and the linked data communities. Next one. In order to understand the motivation behind the development of the entity name system, it is important to take in mind that there are two different approaches to the problem of assigning and managing digital identifiers for digital and non-digital entities. The first approach is called QURI and comes from the semantic web and linked data community. The second approach is the persistent identifier approach, and we have discussed a lot about this second approach during the webinar. About the QURIs, it's important to bear in mind that this approach is based on the idea of using HTTP URIs and RDF to publish and connecting structured data on the web. The focus is on data cross-linkage and integration, while the persistent identifiers approach, we have said, is more focused on enabling the long-term access and use of digital resources. Next slide, please. Both approaches present several issues, and we have already discussed those related to persistent identifiers. About the QURI approach, I want to focus just on one specific issue, that is the multiplication of URIs for the same entity, because the entity name system has been developed as a solution for these specific issues in the linked data community. The idea is to provide a web-scale open service to foster the systematic reuse of globally unique identifiers for entities for different type of entities, not only digital object, authors, people, but also organization, location, and artifacts, and so far and so on. Next, please. In the next slide, you will see in a while, I've reported a concrete example in order to explain better the difference between the link and open data approach and the ENS approach. Imagine that you have two different databases publishing information about a specific entity, in this case David Jarretta, by using two different URIs. The link and open data approach assumes that in order to create a linkage between the two URIs, you can just state through same as statement, indeed, that the two URIs refer to the same real-world entity. The ENS approach, on the contrary, is based on the idea that you can there is an infrastructure, a global infrastructure, that means and manages globally unique identifiers for entities. So different sources can use the same ID to have a direct into the information across them. Of course, the entity name system, it was thought as an infrastructure to maintain also the alternative IDs for the identified entities within the system. Next one, please. The ENS infrastructure was originally developed to include some core services to address some fundamental requirements. The first service is storage. It is a large-scale entity repository to ensure the uniqueness and persistence of the binding between an entity identifier and the related entity. The matching service was built to make identifiers searchable and easily retrievable by humans, but of course also by applications. Maybe the most important service for the purpose of this presentation is the mapping service, which is aimed at storing known mappings between the entity name system identifier and the other available identifiers for the same entity. And finally, the lifecycle management to support a few basic operations to maintain the life cycle of the identifiers within the system. Next slide, please. Okay, this is the ENS infrastructure and the vision that is based on three core functionalities: the assignment and management of globally unique identifiers for digital and non-digital entities, the functionality of providing an ENS resolver to resolve an entity name system to a small set of information, identification information, which includes also external references. And finally, managing the mapping between the ENS identifiers and other identifiers referring to the same entity. Next slide, please. In the next slide, you see the ENS interface. You can see the kind of information that you get through a keyword query about David Jarretta in this case. Through this query you get an entity profile which includes some basic information about the entity that is used by the system for the matching purposes. Interesting thing is that within the profile you can have information also about related entities which have been identified within the system, like for example the City of London. Then you get, of course, the global ENS ID, the list of alternative IDs related to the entity, and you can see from the slide that there are some cool URIs, but also persistent identifiers. like the ORCID ID and the ISNI ID for the entity, and finally some links to external resources. Next slide, please. So I've started this presentation. Okay. In this slide, you can see that it is possible, of course, interact with the infrastructure not only through the web interface, but also through APIs. So these are software-to-software interfaces through which you can get information in an automatic way from the repository. For example, you can use a DOI to get the ENS ID, or you can put a keyword query and get the ENS ID, or use the ENS ID to get alternative IDs. Next one. I've started this presentation saying that the ENS it can be conceived as a solution for bridging the gap between persistent identifiers and cool URIs. However, the original version of the ENS presents some weaknesses for both approaches. In particular, it's a straightforward solution about the linked data cool URI approach. Is a straightforward solution for data integration and mashup through HTTP resolvable and reusable URIs, but it suffers of centralization. It can appear like a sort of authoritative cool URI provider, because there is no separation between the ID and the resolver, and the unique resolver of the original version was that provided by the ENS itself. For persistent identifiers, the ENS can appear a good technical solution for managing interoperability among persistent identifiers, but it presents a lack of organizational and social infrastructure around it, and can be also there can be also a lack of value-added services for relevant communities provided by the system. And then there is a problem of maintaining the data quality managed by the system. The next slide, please. In order to address the weaknesses mentioned in the previous slide, we are currently developing a new version of the ENS that is conceived to satisfy the requirement of persistent reference for entities, but is also compatible with the idea of non-authoritative resolution for linked and open data, and also with local trusted resolution for the persistent identifier community. The key technical change in this new version is based on the separation of the identifier token from the resolvers. In this way, different resolvers, local resolvers, can be associated to the same token. The ENS resolver becomes just a default resolver to get the relevant information about the entity, but the same ID can be embedded within cool URIs for web content, but also for persistent identifiers for achieving trusted information managed by trusted communities and institutions. Next slide, please. So in the next slides, I have advantages of the new approach for the cool URI and for the persistent identifier. So we should see that about cool URI in a while. So the new version of the entity name system presents a light form of centralization just to ensure the uniqueness and persistence of the map, the linkage between the identifiers and the entities, but also the alternative ID mapping. It's not an authority for managing data, and it allows the development of higher level services, added value services on top of the infrastructure, which provides just the basic interoperability services, and is an open distributed platform. In the next slide, you will see the advantages for the persistent identifier communities. The fact that the ENS provides a layer of persistence for the binding between the identifiers and the entities. The idea that the ENS identifiers used as pointers to trusted data and services managed by third parties. The idea that the infrastructure is a neutral ID management infrastructure. So this is not another persistent identifier system. This is an ID management infrastructure for managing interoperability between currently available systems. And it's an enabling infrastructure to build added value services on top of the infrastructure. It combines the trusted mappings with persistent identifiers, but is also compatible with the QURI approach, and should be managed as an open governed by an international board and a trustee. And we are planning to involve much more stakeholders on the governance level to address some trust requirements that have been listed, for example, in the interoperability framework of APARSEN. Next slide, please. So concluding remarks, the ENS is not intended as a replacement for any existing identifier solution, but is an interoperability infrastructure for identifiers. So the ENS ID can be seen as aggregators to get information like alternative IDs, external data, vocabulary mappings, and services. The ENS ensure to keep the identifier management independent from content on the implementation of added value services and vertical solution. And it is conceived as a reconciling solution fully compatible with existing persistent identifiers systems and related requirements, but is also open to the web content through the integration with QURIs and linked data. The final slide shows our vision of an interoperability infrastructure for digital identifiers, which is not only based on the core services for interoperability between identifier solutions, but is much more in line with the APARSEN interoperability framework in the sense that considers also the layer of interoperability at the level of metadata, like we have seen the idea of exposing information according to a common agreed model, or at least to enable different models to interoperate between them. And finally, the last layer that you should see in the last slide is the layer of trust, because the infrastructure should be compliant with the policies of the different identifier system which are made interoperated through the infrastructure. So they should be able to communicate policies, rights, provenance, authenticity information. All this infrastructure should enable the development of value-added services, which can be managed by third parties, and third parties can build their business models on these value-added services. So I'm finishing here my presentation. I'm able to answer some questions in case. Thank you.
Thank you, Barbara. It is indeed another attempt for interoperability, and that is interesting in itself. I have the same question to you as I had to Anila, and that is, how does Maurizio's model work with the ENS?
Okay, I think that there are a number of points of contact between the interoperability framework and the proposed by Maurizio and the ENS infrastructure. In particular, the ENS infrastructure could provide some basic services for the mapping between persistent identifiers and also cool URIs, so it can be used for implementing the services, the added value services that Maurizio tried to show, for example. The good thing is that this can be managed automatically instead of asking to the content providers to expose the same as relationship between persistent identifiers. We can manage these directly through core services and provide infrastructure to implement other services on top of it.
Okay. Okay, thank you. That's clear. We've run 10 minutes over time, and but we still have a good number of people in the audience. Our very last element on the program is David, to bring us some conclusions on this wide spectrum of different aspects that we've heard today. David, do you think you can do that in less than 5 minutes?
Oh, I think I can do it in 1 minute. I mean, it's clear that, of course, APARSEN was set up to defragment the digital preservation domain. We've seen here there is considerable, or there has been considerable fragmentation in the persistent identifier domain, and even as we heard, the fragmentation of the fragments. But I think the hopeful thing is that it does look as if there is some hope. Several pieces of work, especially the interoperability framework and the underlying concepts there, and the ENS, which look as if they can bring things together in the near future. So I think I'd just like to end on that optimistic point.
Yeah, okay. Yes, and if indeed, if the interoperability framework works, then we might assume, as also the speakers confirmed, that all their own identifier systems can, without much trouble, be combined in that model, and then services can hopefully be built on top of this. Since we are running over time and losing people every minute, I would like to express a big thank you to all the speakers. I know we made it hard for you to speak shortly and still address many complicated issues, but I think it was an exciting tour around the horizon of all the work that's happening there. I also have a big thank you for Maurizio, who helped to compose this webinar with so many interesting speakers. Thanks a lot, Maurizio. And we have I want to say to everybody who is here, we have 2 more webinars to go for APARSEN. This was number 12, I think, and we have 2 more. There will be one in September about integration and a common vision on digital preservation. And then we will have one in November on the launch of a virtual center of excellence for digital preservation.